So Alex, what I propose to you today is to talk about tractive ability. This is perhaps one of the performances most expected from farmers and contractors. So the idea of today's video is to check the 3 essential points to ensure you're optimizing the traction of your tractor to the maximum. Traction capacity is simple. It's when your tractor needs power because there's a resistance applied to the tractor, usually at the rear, from an implement that's stuck in the ground. And here we need to transfer the power to the soil, and sometimes even in difficult conditions, e.g. very loose and wet soils, where the transfer of power will be key to working in the field and complete the task.
What types of implements require high levels of traction?
Well, listen, the jobs that require torque, therefore requiring high power. The most popular, as you can see here, with this implement is ploughing. Ploughing is very important, and this is where, generally speaking, all the engine power is required. And you also have a subsoiler, where you have an implement that is not necessarily very heavy, but which is deeply inserted in the soil and that requires high power transmission. We also have a set of tines for lighter cultivation, which cultivate a wide area of soil. We can have a need for high traction here too.
Do I need high traction when I'm drilling?
For drilling and spraying, etc., clearly, these are not jobs where we need high traction.
So when I have high wheel slip, it means that we don't have enough traction from the tractor?
Listen to this. The question of wheel slip is raised very often. In any case, you have to take the slip rate as an indication. It's certain that if you're at 20, 30, 40% of wheel slip, there is a traction problem and you can't make an implement work. So with very high rates, effectively it means that you don't transmit the power to the ground from your tractor, whether it's on tracks or tyres. To resolve this, the idea is to reduce the slip rate and to improve the power transmission, and to lower the slip rate, contrary to what you might think, it's not 0%. We've discovered in our test that you need a certain slip rate to get the most traction from a tyre and maximise performance. So we estimate that between 10 and 15% is an acceptable slip rate and allows you to get the traction you need to make the implement work in a high traction operation. For tracked tractors, we need more like a 5% slip rate. So you have a slip rate which is lower, but you're really comparing two pieces which are totally different. So we will say that for tyres, between 10 and 15% is still acceptable, and for tracks, around 5% is very good.
So what can I do to optimize the traction?
That's the question of the day. How to optimize traction? There are 3 points. The first point is to check that you're well equipped with the correct tyres, or even tracks, but today we're going to concentrate on the tyres part. The second thing is to check if we have the right pressures, and we know that this is a subject which is not simple. It's difficult to determine pressures because we don't always have all the elements to be able to do this. And the third thing, is there enough load on the tyres? Because we know that ballasting has a significant impact on traction performance.
So what are the best practices for tyres?
Well, listen, tyres, if there is any advice we can give, which is very simple, it's always to use the maximum diameter tyre, the maximum approved diameter. If you have a tractor like the one behind you, it's a John Deere 8R series, this tractor will be homologated with rear tyres up to 2.15 metres. Simply, we advise you to use a rear tyre that is 2.15 metres, like, for example, a 710-75R42 or a 960R42. These are two tyres that are both 2.15 metres in diameter, and in fact, use a tyre that is larger in diameter. It will be more effective in turning engine power to traction. On the other hand, for example, let's imagine that you undersize your tractor's tyres and use smaller diameter tyres. Obviously, the wheels will have to make more turns to do the same work and transfer the power to the soil, and with increased wheel slip. So always remember, put the maximum approved diameter tyre on a tractor. If it's homologated for 2.05 metre rear tyres, use a rear tyre with a diameter of 2.05 metres. We've done tests by underdimensioning tractors' tyres. We took a tractor, for example, approved for rear tyres of 2.05 metres, and we put on 1.95 metre rear tyres, and we made comparisons between the two. With the same tyre section width, that's to say two tyres, for example, that were 650mm wide but with a different diameter. And we discovered that on average, according to the different tests, the different ranges, we have between 10 and 15% of difference in productivity. This means that if you run a race of 100 metres when your tractor, which is equipped with a 2.05, has finished, the other one will be at 90 metres or even 85 metres. And finally, to finish on the good practices in terms of tyres, you also must consider the tyre's section width. It's clear that if you have a tyre that is 710 section width and you have another tyre that is 480, you'll have longer biting edges on the ground. We're talking about the lugs on the ground. I prefer to talk in percentage of rubber on the ground. It's more reliable. So you're going to make a larger footprint, so more contact with the soil and with longer biting edges, so you're going to be able to transmit more power, so the tyre's width is going to affect your traction capabilities. And the last important point is the technology of the tyre, because if you're using tyres which are, as we saw in another video, marked as VF, the tyre will be able to carry higher loads at lower pressures than a standard tyre of the same size. And also, at a lower pressure, giving you a longer footprint, will allow you to have more traction capacity, since you will have more tread bars on the ground.
Okay, I understand better. That's why I'm often told to lower the pressure to increase my pulling power?
Yes, exactly. This will greatly improve performance. An easy win, it's just that. Get the pressure right, with the most effective tire construction, and optimize it. That's why I suggest we look at the Michelin apps. There's an app called Michelin Pressure Calculator where you can fill in your tire details, your implements and their configuration to get the right pressure advice. But what you have to remember about the pressure is that you must always determine the load and speed. These are facts that we must know, since all tires are designed to support loads and speeds at a given pressure. And if you consider that your pressure is too high, let's say you have 1.6 bars, 1.8 or 2 bars, it means that you have to look at another tire technology to get lower pressures. Or else, potentially, look at another implement to reduce tire loads.
So finally, if I summarize, if I have the right tires with the right pressure, I'm good.
There's one last point to check. Let's imagine that you have the latest generation of tires, low pressure, the right diameter, the right width, you've checked your pressures with the manufacturer's documentation for its application, you've done all you can. Then if you find that you still have a high wheel slip and you have difficulty in transmitting power, there's an important point to consider and which is very much used, especially by the manufacturers. It's the notion of weight-power ratio, because if you have a tractor which is very light and you put behind it an implement which requires high traction and you don't have enough weight on the tires, it will have difficulty to transmit all the engine power required to the ground. So that's why we're going to talk about ballast, to make the tractor heavier and to get this power transfer.
And what solution do we have today for correcting?
Well, listen, there are several means of ballasting, the most popular being the front weight block, which is widely used and which also allows you to rebalance the tractor with the implement on the rear. And then you also have wheel weights. On high-powered tractors, we see many machines with 300 or 400 horsepower fitted with tires, and to add ballast effectively, we add wheel weights inside and outside. It's not unusual for tractors with 400, 500 that can sometimes have up to 2 tons of rear wheel weights added. So these are the two main types of weights and ballast that exist. There's also water ballasting. Water ballast, main advantage is that it's less expensive. Water is put in the tires, and when you have tires that are 900, 710 wide, you can put a lot of water in them. You can almost put 1,000 litres sometimes. It's going to be almost 1 ton. Another advantage of water balancing compared to the weights attached is that the weight rests in the tyre and not on the tyre. A wheel weight you put on the hub, and here the load rests on the tyre and you have to increase your pressures. So if you increase your pressures, you reduce your footprint. It's true that the advantage of water ballasting is that you don't touch the pressures. You'll check them more regularly because your air volume is reduced. There will always be some air left. A fully water ballasted tyre is only 75% of water, so 25% air left, which is why you always check your pressures more regularly. But on the other hand, water ballasting allows you to use the same pressure while gaining weight. And then there are different types of other ballast that exist, like weights that are put on the rear linkage.
So what is the right weight I should add to my tractor?
That's an excellent question. What's the right power to weight to optimize the traction of my tractor? We hear a lot of things about this ratio. There's a reference that you can have in mind. It's 50 kilo per horse. Well, I want to tell you that if you have an excellent traction and you see that your ratio is 35 or 40 kilos per horsepower, there's no point in adding unnecessary weight on your tractor if the traction is good. No more. On the other hand, if you find that your traction leaves something to be desired, that you have a very high slip rate, then what you can do is actually go for a higher ratio of weight to power and to have in mind a minimum of 50 kilos per horse. This will allow you to have a reference point and tell you how much weight to add in ballast in terms of kilos or in terms of water ballast, for example. So 50 kilos per horsepower is a good reference, which is also taken as a reference by some manufacturers, and for that it's simple. You take the nominal power of your tractor. For example, we take the example of a tractor that would have 200 horsepower, and you realize that with the ballast and its basic weight, we have a configuration weight of 10 tons. You're going to take 10,000 kilos divided by 200 horsepower, then you have a ratio of 50. Let's imagine that your tractor is 8 tons and has no additional ballast, and that it didn't have any special equipment to make it heavier. In fact, if you take 8,000 kilos divided by 200 horsepower, well, you're at a ratio of 40. So you know you have 2 tons to add. If you want to get the optimum ratio when you have an 8-ton tractor, you don't get the power done.
After adding the weight, is it good? We have nothing more to look at?
Listen, there's one more thing. It's using dual tyres. This is sometimes used to get additional traction capacity because the advantage of extra tyres could be duals or even triple tyres, common in the United States, and it will allow you to double or triple your tyre footprint. And as I said at the beginning, it's the same logic. You're going to have a larger footprint, so you'll have more biting edges, which will allow you to transmit the power more effectively. We sometimes see tractors in dual front and rear tyre configuration that are set up this way to get the power to the land for work such as ploughing, subsoiling or other cultivation. So dualing or twinning tyres is more often used in agriculture to reduce soil compaction and preserve the soil for work such as soil preparation or drilling. But it's also used to get more power transmission.
Well, that's quite a lot of information, so what should I remember?
You're right, that is a lot of information, and I didn't promise you that it would be easy. But 1, you check that you have the right tyres, the maximum approved diameter, the width of the tyres, the tyre technology. 2, you'll check if your pressures are optimised for the load and the speed, if you manage to have low pressures and transfer the power to the land. Once you've looked at pressures and you still have a power transmission problem, then advise you to look at the power-to-weight ratio to make sure that you have the right balance of ballast to transfer all the power required into tractive effort. And if despite that, after checking these 3 points, you still have problems, you have to ask yourself questions about the balance between your tractor, your tyre equipment and the implement you're using.
And finally, if I use tracks, am I okay?
Excellent question. Listen, regarding tracks, I suggest you watch our video, where we will see that the tracks have quite interesting traction capacities, and we will have some comparisons between tyres and tracks that we can analyse together.